We are starting with the first chapter in ninth class, matter in our surroundings. First of all, we should know what is a matter. Matter is anything that occupies space and has a mass. And one thing more is required here, that it can be felt by one or more of our senses. Then also that thing is a matter. So anything that occupies space, has mass, and can be felt by our senses, then that thing is known as a matter. Example of matter. Now again, you can see anything that occupies space, for example, air. It occupies space, has mass. Air has mass. Water, it occupies space and it has a mass, so this is a matter. Stones, plants, animals, wood, etc. All these are examples of matter. Matter is made up of very small particles. How we can say matter is made up of very small particles? Example, a piece of chalk may appear to be continuous but can be broken into small pieces. This shows that matter is actually made up of very small particles. After knowing what is matter, coming to the next part of this matter, characteristics of particles of matter. Characteristics of particles of matter. We are taking 4 characteristics of particles of matter. First, there are spaces between the particles of matter. Second characteristic is particles of matter are continuously moving. They are continuously moving. And third characteristic of matter is particles of matter possess kinetic energy. Kinetic energy is the energy required for movement. Fourth characteristic of matter is particles of matter attract each other. So these are the 4 characteristics of particles of matter that we are doing now one by one in detail. Number 1, first characteristic. First characteristic is there are empty spaces between the particles of a matter. To understand this, I am taking an activity. Take 100 ml beaker. This beaker has a capacity of 100 ml. And to this we are adding 50 ml of water. We are adding 50 ml of water to this. And I'm showing the particles of water here. Though we cannot see them with naked eye, so these are actually magnified water particles. So in 100 ml beaker, we have taken 50 ml of water. These are magnified water particles. Now to this water, we are adding some salt. So I'm taking salt here in a spoon, and this we are adding into the water. But before adding this salt, we have to mark the level of the water. And after adding this salt, again we have to check the mark of the water in a beaker. Now observe what will happen. Salt particles in solution, they will actually go into the spaces between the water particles. Between these water particles, there are some spaces where the salt particles will go. And you will see that level of water will not rise. Even after addition of salt, the level of water will not rise. It will remain the same. So where does the salt go? Like I told you, it will go in between the spaces which are there between the water particles. So this activity proves that there are spaces in between the particles of matter. There are spaces between water particles where the salt goes. That is why the level of water remains unchanged even after addition of salt. So this is our first characteristic of the particles of matter. Moving on to the second characteristic of particles of matter, that is, the particles of matter are continuously moving. The particles of matter, they are continuously moving. The evidence for this characteristic, particle movement in liquids, was first noticed by Robert Brown. In liquids, first of all, this was noticed by Robert Brown. So what he did, he added extremely small pollen grains in water and viewed them through a microscope. And he found that these grains are moving in a zigzag way. Like when he added these pollen grains in water and viewed them through a microscope, this one pollen grain, he saw that it is moving in a zigzag way in different directions. It is moving in zigzag way. This random movement of the particles is called Brownian movement. Brownian movement is the zigzag movement of the particles of matter. Now this was to know that particles of liquids are moving. Now particle movement in gases. Particle movement in gases. Now you all have observed this thing. When a beam of sunlight enters a dark room through small openings, the tiny dust particles suspended in air can be seen to move randomly in zigzag way. So we can see the gases also moving in a zigzag way. Now I'm taking second activity for this. Experiment. To demonstrate motion of the particles of matter. To understand that particles of matter are continuously moving, place a bottle containing concentrated solution of ammonia in one corner of the room. Ammonia has a very strong smell, and remove the stopper of the bottle. So ammonia gas will come out from that bottle, and what we will observe? It is observed that ammonical smell can be felt even at the other corners of the room. So this indicates that the particles of ammonia are moving. That is why we can smell it in all the corners of the room. Or another activity to understand this, place unlit incense sticks. Incense sticks are agarbattis in one corner of the room. And now ignite the incense sticks. What we will observe? We can smell the incense sticks fragrance in all corners of the room. Though we lit it only in one corner, but we can smell it in all corners of the room because the particles in the incense stick, the gas particles in incense stick, they are moving and reaching to all the corners of the room, and the smell in these particles, we can smell those. So it is evident that particles of matter are continuously moving. Moving on to the third characteristic of particles of matter. Particles of matter, they possess kinetic energy. Like just now I told you, kinetic energy is the energy required for movement. And this kinetic energy of particles increases. How it will increase? With increase in temperature. Kinetic energy of particles increases with increase in temperature. Now again, to understand this, we have an activity, experiment to demonstrate that particles of matter move faster. When they will move faster? With rise of temperature. So how will demonstrate this, that particles of matter move faster when there is rise in temperature? We'll take two beakers and mark them as A and B, and add 100 ml of cold water Let's say the water at room temperature 25 degrees Celsius will take in this. And in another beaker marked as B will take again 100 ml water, but this water is hot water. This is at 25 degrees Celsius and let's say this is at 50 degrees Celsius. And in both these beakers, we will add same amount of copper sulfate, or let's say 1 crystal of copper sulfate we will add into both these beakers. Copper sulfate salt is blue in color. So in these beakers, the copper sulfate crystal will start dissolving. So when it will dissolve in the beakers, we'll see in this beaker, the color is dark blue, while in this one it is light blue. So observation is, rate of mixing of copper sulfate is faster in hot water. That is why the color is dark, because more copper sulfate will dissolve. And for dissolution of copper sulfate, what is required? It has to move quickly. So when it is moving quickly, it is dissolving more and the color is more blue in color. While here the color is light blue because temperature is low, so the movement of particles is slow. Movement is slow because their kinetic energy is less. Here kinetic energy will be more because temperature is more. So this explains that why particles of matter move faster with rise in temperature, because they will have more kinetic energy. They will have more kinetic energy. After the third characteristic of particles of matter, we are moving on to the fourth characteristic of particles of matter. That is, particles of matter attract each other. Particles of matter attract each other. This attraction between the particles holds them together. Because of this attraction only, the particles of matter, they are held together. Again, to understand this, I am taking the next activity, that is to demonstrate the attractive forces. To demonstrate the attractive forces between the particles of matter. To understand this, we are taking a piece of iron or an iron wire, a piece of chalk we are taking, and a rubber band, and we are taking a rubber band. Try to break them by hammering them or by cutting them or by stretching. What you will observe? Piece of iron wire is most difficult to break, but breaking of chalk or rubber band is easy. So this indicates that particles in iron wire, the particles in iron wire are held by stronger force of attraction as compared to chalk or rubber band. Since energy is required to break matter into pieces, it indicates that particles in matter are held by some attractive forces. Since it is difficult to break iron wire, means there are stronger attractive forces in case of iron wire. The strength of these attractive forces varies from one kind of matter to another. It is not same in all the examples of matter, it is different. Like here in this case, it is the maximum in the case of iron wire. This is the fourth characteristic of matter. I'm taking this much only for today and giving you few questions to answer. First is, which of the following are matter? Which of following are matter? Just think. First example, chair, air, love, hate, almonds, thought, cold drink. Which of following are matter? Next question. Give reason. Smell of hot food, hot sizzling food, reaches you several meters away, but to get the smell of cold food, you have to go close. So this is about your first lecture.